Now, just checking. Okay. Oh. So, folks, I will be using the demo code, okay, from this virtual environment on the D drive. Okay. You'll find on these D drives there are two folders, demo files and lab files. These files can also be downloaded separately if you want to run these.
I am, but my module.
Sorry, go ahead. All right. So if you
not everybody is logged into their module or can see it.
Okay. So, no worries. Take your time. Try to log on to the remote environment, which is the Learn on Demand. Okay.
Victor, I don't want to
Yes.
interrupt you, but this is Jenna with Judge Learning. If anyone's having any trouble with the Learn on Demand environment, please let me know. I know about half of you or so did test that beforehand, so thank you for doing that. If anyone's having any trouble, though, please let me know and I can assist you.
So Jen, this is Shrida. I'm logged on to the on Learn on Demand module, and then I've launched the all modules. But what I
Correct.
see is just a screen that says Control Alt Delete to sign in, and just shows me the time.
Okay. Notice on top of your screen there is a command that says Control Alt Delete. That's how you can submit a Control Alt Delete to the virtual machine.
Okay. And then the password would be the one that I used to log into on demand?
No, actually, notice the command menu also has a paste, which allows you to paste your password right into the virtual machine.
Thank you.
No problem. All right. Cool. So once you're on the virtual machine on the D drive, you'll find these demo files and lab files. Lab files is for you. Demo files is for me. Okay. So we're at module 11. So I want to you'll notice on each module there's a corresponding setup.cmd. Now this just initialized the environment so I don't run into anything unexpected. At least whatever the demo script needs. Yes, go ahead. Yes, go ahead.
Mine just shows D drive. There is no D drive.
There's no D drive. Really? It's in the virtual machine, right? Make sure the virtual machine you're looking at is the MIA SQL.
MIA SQL. Okay.
So make sure in the machine tab you're logging onto MIA SQL, not MIA DC. That will be domain controller. That doesn't have a D drive on that one. Cool. All right. No problem.
Okay. Thanks.
Sure. All right, so the database we will be using is called the T-SQL database. Okay, and you'll notice that we already have a few views. Now again, views are great if they are going to be permanent and if you need to place security on them. Okay, easy select from the view. Right click. Okay. You can use script view as. Alter to. New query window. Now by right click on things, folks, to learn about SQL Server, it's so easy. You just have to right click everywhere, okay, and just explore everything. If it's not right clickable, it's not doable. No, I'm just kidding. But get you started pretty quick. So if you want to see a view definition, there you have it. Okay, so this allows you to modify the definition of the view. Fair enough. Now this view is meant to take the orders table and orders detail and combine them into a simple spreadsheet like results. Okay, so when someone uses this view, it's pretty easy. Okay, I'm still trying to see how long I can go without touching the keyboard. Okay, not long, pretty sure, not long. All right, so here you can start from, select whatever column from the view, and the view's definition will execute, which is pretty standard SQL. Any questions about the views? Okay. Now, what makes a SQL Server view sort of cool is that in addition to be read-only, okay, SQL Server's view supports indexing. Okay, so it's possible to take a view and create index on top of these columns and thus materialize the result. Now, obviously, it's only useful on more of a reporting table where the data is mostly static because the index has to be maintained, obviously. Okay. All right. So back to the demo code I was talking about. Okay. So each of these module 11, for example, we're working on module 11. There's a setup.cmd. Just make sure you right click and run as administrator if you want to follow along with the demo code. Okay, just make sure you run the setup cmd as administrator. Now each module has a corresponding demo folder. Now that is a SQL Server project file that includes well, query files. So we'll be using this to save me from typing a whole lot. Okay. Okie doke. So creating view is a straightforward process. As long as you know what is your view made out of, just if it runs, you can create a view for it. Make sure you're in the right database, T-SQL. Okay. Now this will subsequently create a view based off of that. Okay. Now, while you're executing, I think it's a good time to cover things as we go. Okay. Besides taking the query and run it, this tool can give you a whole bunch of information as well. Now, specifically these three little buttons that you see. All right. So the first button that you see right here, called Display Estimated Execution Plan. Okay, so by using this button right here, it's going to explain to you what is the plan the server is going to do to give you the data you want. Okay. Now, each one of these little strange looking icons that you see here is an exact step that the server must perform. Okay. Now, I promise you these are all English. They are all English. I know, right? And there's no black magic. Okay, there's some black magic, but not a whole lot. Okay. If there's black magic, it's only because I don't know what it is. So I'll call it black magic. But all it's trying to do is trying to read, it's trying to scan an index. In fact, you can put your mouse over and see what it's trying to do. Okay. It's trying to physically read a clustered index. Okay, towards the end of this session, I'll go over the entire index scenario. But again, this is the execution plan explained. So that's what it is. Okay. Now, as opposed to this icon right next to it. Okay. So this guy is like, ask Google Map how to get there. Okay, so that's like asking Google Map how to get there. You're sitting in front of your computer. You're not actually leaving your house to go anywhere, you just ask Google, this is how would I go about going to Washington, D.C. or some other place? Okay. Now that plan is just a plan. It hasn't been fulfilled. It hasn't been executed. It's just what we know based off of statistics. Fantastic. That's good. Now this guy right here is when you actually leave the house and start recording every steps. Okay. So for example, this is going to have an estimate of how many reads, how much memory to use, how many records will be returned. Now, the actual plan, the actual thing, this is really what happened. It's kind of long, I can't type over it, but the one to the right is going to tell you this is really what happened. So there are two icons that gives you almost the same results, but just keep in mind that one of them is tell me what is the plan. Okay. So notice this is actually a toggle switch. If I click on it, it stays lit. If I toggle it again, it turns off. Okay, so if I keep that on and I execute any query right next to it, okay, is the actual execution plan. For something this simple, the plan is going to be the same as the estimate. We'll spend more time towards the end, but just keep in mind this is why every time, I'm going to keep this button on if I can remember, so every time I run a query, bam, it's going to have an execution plan tab right next to it. Fantastic. All right, so this plan is simple because our view is simple. Our view at this moment is just trying to reduce the number of columns we are exposing from the table, right? So a more complex view, on the other hand, oops. Okay, folks, again, this is a warm-up section here. So here we create a view. Okay, now this view is somewhat more involved. We call this complex view because we're taking the employee table and join the order and order detail. Okay, and our goal here is to figure out by the year how much sale has each employee made. Okay, so when you run this, the execution plan is somewhat more involved because we have at least three things we need to get data from. Okay, so if we have three places we need to get data from, we can say we want to do this guy first, that guy second, that guy third. Or we can say we want to do this guy first, this guy third, this guy second. Okay, so this execution plan will tell you from the rightmost, this is the first guy we accessed. And then we're going to do this, in order to join this guy. So this is step 1, this is step 2, this is step 3. Okay, and then this is step 4, and this is step 5. So it reads right to left, top to bottom. Okay, so this is this is essentially a roadmap that tells a piece of software how to get your data. Okay, so it's really not that much of a black magic. Okay. All right, so my demo.ssln is empty. If it's empty, it's probably because the Solution Explorer is playing hide and seek with you. So to see this window right here, bam, oops, I don't see anything at the moment. Holy smokes. Oops. Ah.
Welcome to Reservationless Plus conferencing. Enter your conference code, followed by the pound or hash sign. Sorry, you may have entered an invalid conference code or dialed an incorrect number. Please verify and try again.
Hello? Hello?
Hello?
Hey, Jenna, did you conference me back in?
Hello?
Hello, can you hear me?
Victor?
Hello? Yes, can you hear me? Hello, can you hear me?
Hello?
Welcome to Reservationless Plus conferencing. Enter your conference code, followed by the pound or hash sign. Thank you. If you are the leader, press star now. Please enter your leader PIN, followed by the pound or hash. To start or join your conference, press 1. You will now be placed into conference. To mute your line, press star 6. To unmute, press pound 6. After joining the call, to record the conference for those who may miss this call, or for future playback, press star 2.
All right, folks, I'm back. Apparently, in a panic of hanging up the incoming call, I hung up the ongoing conference call. So this happens sometimes. Note to self: next time, don't panic. All right, so folks, if you don't see any files in your Solution Explorer, actually, by the time it's good to check if you all can hear me. Can you all still hear me?
Yes, we can actually.
Fantastic. All right.
Little breather while you were gone.
Thank you.
All the information is overwhelming.
Already? Okay.
Just pulling your leg. Let's move on.
No worries. More coffee. If you don't see the files, go to Solution Explorer, and you will find that all of your files are actually right there in the Solution Explorer. Sometimes it decides to hide from you. All right, fantastic. So, cool. All right, so this is what View allows you to do is by keeping a somewhat highly normalized table into, consumable information. So this, well, somewhat consumable. We can see employee ID 1 has sold that much in 2008. So that's better than the things like, well, if you look at the underlying tables, the underlying tables is fairly normalized. Okay, so if you look at order details, okay, this captures individual transaction details, but it doesn't actually roll things up into usable form. So fantastic. So we know we have views from. Actually, to tell you the truth, I think my first view must have happened in like 1996 or something. So this is nothing new. Okay. And from time to time, whenever people mention 1996, I feel like it was just yesterday. All right, so you can select from views. Fantastic. All right, and if you no longer need the views, you can drop them. Okay, so while view is great, they're mostly useful if you decide this view can be reused over and over. Okay. All right, so there are a few shortcomings about views. Okay. some of the shortcoming about the view is number one, obviously it's a permanent object. Okay, and number two is view is treated like a table. Okay, so view is designed to produce a table for you to consume. Now, sometimes you just don't need all of the data. For example, in my previous demonstration, notice how I was able to produce a list of all employees and their sales. Okay, but what if what I'm interested is this one particular employee or this one particular department? I may not want the server to go ahead and produce me the result of the entire view and then filter out what I don't want to see. So take this as a hypothetical situation. I have 200 employees, okay, and perhaps at the moment I want to use the view to see how much each salesperson generated in a particular year. So let's say my business has been running for 5 years. So there are 1,000 records I need to produce from the view. Now I am probably interested in this one person for that 1 year, just to throw away 999 things that my view has to produce. That probably calls for some optimization right there. All right, so let's look at what we can do further. Okay. Now this is something fairly unique to Microsoft SQL Server. Okay. This thing right here is a function that returns a table. Now, the function only returns the resulting data, obviously based on what you put in as parameters. Okay, so when we run it, it's not all that impressive, to tell you the truth, but it's a good starting point. So here's the dbo.getNums. This is the second demonstration file from module 11 demonstration B. Okay, but this will get us started. Okay, so notice when I run that, bam. Yeah. Okay, how did I get back to master again? I need T-SQL. That's why there's a use T-SQL on top. Okay, so just to make sure I'm in the right place. Okay, so this function generates number from 10 to 20. All right. So notice we can use this function called table value function as a way to customize what the view returns. Okay. So let's see how a function is created. In order for it to be a table value function, we call this TVF, table value functions. Okay, we have scalar functions, we have aggregate functions, we have analytic functions. So, just to keep things coherent, we have scalar functions. One row in, one row out. If you want to see some scalar function, just to make sure that we know what we're talking about here, under programmability of any database, it doesn't have to be any database specifically. Okay, I'm going to use T-SQL. If you can't find your Object Explorer, it might be on the left-hand side. Just put mouse over it. Okay, click on Connect. We'll connect you to the database. Okay, now, hey, welcome back. So under T-SQL, you'll find programmability, and you'll find functions. Now, in this function, you'll find scalar value functions table value functions. These are all custom stuff. These things that we write. There's also system function that's out of the box. So out of the box, we have, well, datetime function. That's scalar, isn't it? One value in, one value out. Okay, I'm sure you're all familiar with some of these functions, right? Datetime function that manipulates the date. Get different parts of the date. Okay, so these are all scalar functions. One row in, one row out. Now you may want to take some time. Mathematic functions, sure. One value in, one value out. Scalar. Okay. String functions. Cool. So we got those functions out of the way. Now we also have table value functions. That's what we're going to talk about here, which returns not a single value, but returns a table. Now, the most user-friendly version of the table value functions is something like this, single query. Okay. So this function in its entirety is made out of a single query. Now, of course, at some point, this query is going to make use of the parameter, right? Otherwise, why did we write a function to begin with? So here is a sales dot function. That's just good convention. So in other words, give me an order ID, and I will tell you your line total. So whatever the query returns, awesome. So we're going to pull from order details. We're going to retrieve order ID, product ID, unit price, quantity discount, and so on, and then calculate a line total. Okay, so that's what our function is made out of. Bam. All right. The awesome thing about demo code is they usually work. Awesome. All right, so now we have this function. Let's see how we can use it. All right, so this function is now being invoked with that particular order ID as its input parameter. Fantastic. So now I'm going to use this function. Bam. All right, so here we go. Perhaps. That's easy. Cool. All right, so you can now put in whatever value. And your table value function produces a sort of like a virtual table, so you can do your thing. Cool. Any questions so far? Okay. All right, I'll just give you a moment to think about some questions while I just try to throw in a few additional things. So, folks, you're going to see me typing a few things, but if you're having any questions, please let me know. But I'm just going to write that. Don't you just love these red wiggly lines that tells you that you're doing something wrong? It's fantastic. Love it. The reason why you got this red wiggly line was because ambiguous column names, right? Right? Because I joined the product table, so there are two product IDs. So it's just like ambiguous. Which one are you talking about? So no idea. So I give you a wiggly line. So now I can look at the product name. Okay. And you'll notice I can use this table value function just like a view. I can join this to another table to get more information. Okay. I know there is a question that you're thinking at the moment. Actually, I don't know if you're thinking about this at the moment, but what about this guy? How do we actually, before I move too fast and becomes truly overwhelming. Okay, so this table value function allows you to supply a value. Okay, and produce a parameterized view. Now, creating this function is also very straightforward. Simply do a return of a single query. So we call this single query table value function. Now, the other kind is called multi-statement table value function, which in that case you are given complete freedom in so in the second type where you have the multi-statement TVF, okay, you will return a table, but you can construct a table whichever way you like. It doesn't have to come from a single table. It can be from multiple table union and so on. Okay, so it's called multi-statement TVF. Now, Dennis has an awesome question. Can you index TVF? Unfortunately, no. Table value function is executed on the fly. Okay, but it's usually sufficient if you index the table of which you're pulling the data from. Yeah, so table value function itself is not indexable. Cool. All right, so folks, there is no demo files to show you multi-valued or multi-statement table value function. So I am going to do this thing called search engine lottery. That means I'm going to fire off the IE and hopefully Google will answer, but that never actually happens. So anyways, so Bing happened. So there is the multi-statement table value functions. Okay, so you'll find that that's an inline table value, which is single statement. And so notice here you create a variable. Okay. This is a table type variable. Okay, so we have variable that stores an integer, right? We have a variable that stores a string. We have a variable that stores a date. This is the variable that stores an entire table. Bam. Stores the whole table. And that table consists of these 4 columns. And in your table value function, let's see what we're doing here. In our multi-statement function, we are trying to populate this table value function. So you're thinking, whoa, what does that mean? Actually, it means just like what you see. We're trying to insert into that one variable with the result of that select query. All right, so this table value function is trying to find the most recent order, right? So the max date for a given customer ID. It's the most recent order for a customer. Okay, once we find what that max date is, we can then go to the sales order header and the sales order detail. I am pretty sure he meant sales order detail right here. Okay, inner join product. Do people not test their code before they post it on Stack Overflow? Guess they don't. So here, there's a order header, right? Join order detail. Okay, for a given most recent date for that customer. Okay, and that select statement's result goes into that table variable and then subsequently returned. Okay, so there's a lot of flexibilities in the table value function. Very cool. All right. So that's table value function. Bam. But wait, we're not done yet. So we got table value function, right? What other function do we have? We got aggregate function. It's awesome, right? Aggregate function is like, take a bunch of rows, input, produce a single output, right? We see this a lot in group by, right? Sum, min, max, average. So these are all aggregate functions. And then we have analytic. Okay, and folks, nobody remembers all of them. I certainly don't. So here, in the programmability, you'll find these functions, okay, where you find aggregate functions. Awesome. And we also have some other functions. Yeah, doesn't have the analytic function. I'll have to show you those. Any questions so far, folks? That's our table value functions. Now this can be used in place of some store procedures that you are currently using. To tell you the truth, store procedure isn't, at least in my opinion, store procedure was never meant to return results, right? Right? If your store procedure returns result, then you're blurring the line between what is a procedure, which meant to do something, perform some actions, versus views, which is to present data. So, strictly speaking, okay, if you need some complex logic, okay, I guess the biggest argument of using store procedures to present data is that I can embed logic, I can take parameters. But with the table value functions, plus views, you should be able to address most of your retrieval need. Okay, so keep store procedure, just like their name sounds. Get. And well, your SP is to change stuff. I suppose that would make stuff easier down the road. Okay. Because after all, store procedure isn't all that join friendly. Okay, can't join this stuff. Right. And later on, you'll see that it's not as flexible as a table value function. All right, so folks, it's good to check in with you. Everyone's still okay? Just checking in. Y'all still hearing me? I haven't dropped off the conference, have I? Happens sometimes. Okay.
No, we are all here. We can hear you fine.
Fantastic. Any questions though? Any questions? Okay. Very nice. Okay, maybe it's well almost time for you to try your hands on this. So no worries. Now next up is this part is called derived tables. It's a it's nothing more than a subquery. Really. So here you go. This is called derived table. It's nothing new here. The point is not to show you subquery. The point is to lead you into common table expressions. Okay. So as you can see, this is not difficult to construct, but it's certainly hard to understand because while some people are better at keeping a mental picture of what this does and what that does, okay, I find it difficult for me to keep a mental tab of what's going on. Okay, so whenever I need to create a derived table, I prefer to take this. Oh, whoa, 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 whoa. Okay, I prefer to take this, right, out of the picture. Okay, and then I paste that query right there. Okay. All right. So here, I just it's sometimes easier for me to just give this a name. Okay, so I'll call it with customer year. Okay. So I give that subquery a name, a label that I can refer to later. So I can pretend not having to worry about the definition of the customer year. And you're probably thinking, wait a minute, isn't this exactly what view is for? Well, it's exactly what view is for, except that this doesn't create a permanent object. Right? Except it doesn't create a permanent object, is all. Now, folks, go ahead.
Victor, Herman here. Quick question. Like most of the folks around here seem to have quite a bit of familiarity with CTEs and some of the earlier topics in your presentation.
Sweet.
Would you mind sort of like, let's say, skip some of us trying it out, since I think most of us have done this quite a few times, and maybe we can move a little bit faster through the earlier topics. I think one of our great interest is in query optimization, as well as discussions around like not only the optimization but also why would I choose one over the other. And you've touched upon that a few times. Like, but why would I use a view over CTE, although they're usually for a very different purpose? Or for performance, would I use a CTE or is a Is a table function faster? Those kinds of questions. If we can hit on those topics a little bit more, that would actually be great.
Fantastic.
And sorry if I just
Yeah.
throw your whole plan for the
No problem. I actually have no plans. My plan is to talk about whatever you want me to talk about. So that's what custom class is for. Yeah.
So yeah, I think topics around performance, query optimization, how to analyze a query, an execution plan, those kind of things would actually be of great interest.
Fantastic. Cool. All right, so folks, let's that's a great point. So, folks, I'm almost wrapping up this topic. So that's subquery and that's CTE, since you have all been using this quite a bit. Okay. This is awesome stuff. All right, so let's talk about performance tuning. At least let's define what we already know and what we might not be so familiar with. Okay, so tuning. Where do we begin? Well, every time we talk about tuning, the first response is that we are always told to write efficient query. Okay, so in order to define what an efficient query is, minimize I/O, minimize CPU, minimize So, in terms of how to allow the server to process your query most efficiently, we're almost always looking at how to minimize these resources. Okay, now again, there's no black magic. Whenever you look at queries and you're trying to select data from it, let's use that guy right there. Okay, come on. Boom. Okay, so let's say we're trying to run a query like that. Okay. Okay. I am just trying to cancel that query and it's not cooperating. Okay. That message just really drives me weird. Okay, so speak of performance, let's talk about I/O in general. Okay, let's say you create a table and you start inserting data. By default, right? Extents are allocated and linked all over the place. Now, without any other structures, we're literally, we're literally trying to shove as much data into database as possible. So in that sense, usually you're looking at marketing materials. It's always talking about transaction per minute. So by throwing stuff into the database without any specific order, you're pretty much guaranteed the fastest transaction per minute. Okay. Now, what is the trouble with that, though? Okay, so imagine there's just two boys, me and my brother. Wait, two boys, me and my brother? Never mind. There's two boys. One boy heard the mom says, go clean up your room. Goes open the drawer, swipe everything on the desktop, and close the drawer. He has the highest transaction per minute. He cleaned up the most number of things in the shortest amount of time, so he gets a candy. The older brother puts everything in exact order in the exact location. He's going to be able to find things later fast, but he doesn't get a candy, right? So that's really the two types of database systems: OLTP versus reporting system. Okay, so OLTP, you're trying to process as much transaction as possible. So you're really trying to minimize the index, the amount of maintenance required to arrange the data. While reporting systems, they usually follow some sort of star schema. Okay, so let me get this. So here, I'm going to run this query. Boom. Okay, fair enough. Let's try that. Awesome. So here's my execution plan. Okay, now for all the execution plan, they are really, the first thing to look for is table access method. Okay. Now, this is one form of table access method. Clustered index scan. Now, a cluster index scan is synonymous to table scan. Now, the only difference is a clustered index scan is against a table that has so-called a cluster index. Okay, a cluster index, if you zoom in to a data file and you zoom in to a table extent, okay, so this big circle is a data file. This blue rectangle is an extent. This red thing is a data page. Okay, so let's zoom into the data page. In a table that has a cluster index on, let's say, employee ID. Just give you an example. When you zoom into that block, you will find the physical storage. Employee ID 1, Victor. Employee ID 2, Bob. Employee ID 3, Tom. In a table that is clustered indexed, the physical storage of record is in the order of the index and right next to the index value is the rest of the record. Okay. No problem so far. Okay, so let's try to do a little dig into this guy. So notice this step tells you, or at least tells me, I am reading from that cluster index. Now, this cluster index happens to carry the name PK, so whoever created the table is doing us a favor by explaining where this cluster index come from, or this index came from. This index is created to support the primary key. Remember primary key? Of course, right? It's unique and not null. Okay, so if I tell you I have 3 employees, employee ID 10, employee ID 20, employee ID 30, and I declare a primary key here. Okay, and I tell you I want to insert employee ID 40. Well, we can look at it and say 40 is unique, 40 is okay, right? But what if I have 10 bajillion, gajillion, quantazillion, googolian, whatever number of records already? Now, it's not so easy to find out, is employee 40 a duplicate or it is genuinely unique, right? So anytime you use primary key, or even if you declare a unique constraint, SQL Server has no black magic to make sure any incoming value is unique, right? So in turn, SQL Server builds a index in order to help determining if a value is a duplicate or not. So here it says we're going to look into that. And this is the projection. This is what we want to see by this access method. Okay. And there are some additional supporting information about this guy. It tells you we actually found 830 rows. We're scanning the whole cluster index. Notice that it can be a scan if you have a predicate, if you have a where clause. Okay, let's look at this. This is the order table, right? Fantastic. Okay, so let's take a look at the orders table. So there we go. So here's the order table. Let me just quickly get some row ID number. So let's say I want 253. That's my order ID, right? So right click, script to table is select to new query window. Bam. Where order ID. One zero two five three. Okay. Cool. All right, so now when I do this, keep in mind this is a table that has a cluster index. So the physical storage of this table is very much like a dictionary. If you find the letter A and you found the word apple, the dictionary is going to tell you the definition of the word right there and then. You don't have to jump anywhere. Okay, so a cluster index is just like a dictionary table. So right at that spot, the rest of the row is right there. Now, am I sure? I don't know. Let's find out. So here's the execution plan. So notice this is only one step. Cluster index seek. So notice the word scan becomes seek because I'm using the index to look for one specific value. And the columns it's producing, fantastic. So that's my orders table. Now notice I have some other non-cluster index. Now these non-cluster index, on the other hand, contains pointers to a cluster index. Contains the pointers to the cluster index. Okay, so folks, think about your home, right? Your home has an absolute coordinate on Earth. We call that GPS position, right? To anybody, I can just give you a GPS position. We'll find your house, right? And also we have non-cluster index, which is something like 123 Main Street, Flushing, New York, 12345. Now, with that kind of information, there are extra indexes. We can use that information in order to find out which physical apartment or physical house that is. Okay, so let's say we have employee ID. Okay. Employee ID, customer ID, order date, non-cluster index. Okay, let's pick a date. That's 06, 07, 8, 6, 7, 8. I can remember that much. Okay, so here. Folks, just making sure you can still hear me okay. Can you hear me okay? Sound check.
We can hear you.
Hey, nice. Thank you. Thank you for validating my existence. Okay, so this is what date am I looking at? So dyslexic 2000. Okay, so okay, my execution plan. Bam. Okay. So let's see this execution plan. So if you look at this execution plan, so first I use that non-cluster index. Non-cluster index is like the index in the back of the book. In the back of the book, if you find that word, you don't actually get the chapter, you get a page number, and then you go to the page number to get the rest of the things. So here, if you see index seek, it's trying to use non-cluster index, and it alone is not going to give you all the information we want, right? We want customer ID, employee ID, order date, required date, blah, blah, blah. We got lots of things we want to look for. So that is going to give us the page number, and that page number is then used to look up. So notice here's a key lookup against the cluster index. So the first one gives us what is the key for that date. Okay. Now you can also, and notice it's kind of hard to see here, but these lines that you see here, these lines, sometimes they're thicker, sometimes they're thinner. The thinner they are, the fewer number of rows. So this is relatively thin, so it has 2 rows. Okay, and now there is the operation called nested loop. You know, for X in first collection do, or sorry, not do. It depends on what language you're programming in, right? There's a for, and there's another for. It's a nested loop. So you have an outer loop, which is this guy, for each item. So this is a to loop on the outer loop, right? And for each outer loop, we are checking against the inner loop to see if we can find the guy. Okay, so actual number of rows, 2. And that's just tells you it's doing an inner join. That's the loop. Now there's a few other join operations, such as hash join, and merge join. Okay. Now, folks, it's not that one join is better than the other. Okay. It just tells you that nested join or nested loop is most useful for equality, inner equijoin. Okay, that's just on well, precise data types. Things like varchar, things that's somewhat precise. Okay. Now, if you have something longer, for For example, a column that contains 20, 30 letters. Comparing them letter by letter is really not that efficient. So we produce a hash table. Okay, and hash table will be, again, used for inner joins. Okay. So we produce a unique hash value, and then we compare the hash value rather than comparing the byte by byte characters. And we also have merge. Merge is mostly comes up when your inputs are sorted. Right. So you have one set of input. So let's suppose you have one set of input. It's already sorted. Okay, so notice as soon as you use this to try to merge join the two, notice AB can be eliminated, right? So that's the first hit. And notice it can now flip the comparator. And notice there's no D. And the pointer is now pointing here. So you notice merge join is very quick. There's no look back or review something that has already been compared. Okay, so now we are at F. Okay. So merge join. So these are the type of join operations and the type of indexes. And in SQL Server, there's only really cluster index. You can only have one. And a non-cluster index, you can have as many as you want. And they're there to help you look things up.
Victor,
Go ahead.
question. So on, let's see, actually two questions here.
Take it away.
Place on the merge, it will only use a merge join when it's sorted, when it's ordered by the columns that you actually join on, correct?
Well, now here's the thing.
Or is it sorted anyway?
If the query optimizer decided merge join is the quickest way for this query to produce a result, and it realizes, one of the input is not already sorted, then it's going to say, how much cost does it take for me to sort this result and then do a merge? If it's cheap, it will actually dynamically sort them and then do the join. If it's expensive, such as it's a very large result set, it might just return back to nested loop.
And another question is on
Sure.
The query optimizer and hints. Since you can actually give hints to sort of override the query optimizer's belief of what the best solution is. I personally never use it because I believe that SQL is better than I am at knowing its data.
Mm-hmm.
But when should you actually use the hints?
I can almost tell you never. I wouldn't personally actually put in any hint because for the fact that hint is static, it might be very good the day you put it in. Now, 10 days later, 10 million records later, the data distribution may change. Your I/O statistic may change, and the trouble is most people forget to remove them when the hint outlives its usefulness. And I mean, Query Optimizer is this thing where I would say most of the R&D budget in SQL Server goes into tune this component. So you can certainly put hint in there if you. I have yet to find any solid case where the hint actually does better in the long run. And I have actually seen more of me tuning the query and say, why is the optimizer doing this? and then you go back and look at the query and go, there's a hint. And then no one's actually explaining why the hint was there in the first place. Because Query Optimizer really figure things out by statistics. So if the optimizer is giving bad plans, there's usually one of the few things, right? One is incorrect stats. So I'm going to make sure that that is taken care of first. And two is unused structures. Okay. So for example, even when you have things like this, right? Notice how we are using a where clause where order date equals that, and it works really well. Okay, it's using the non-cluster index. Okay. But if I change that, equal to, order. Notice this is something that is more things you need to watch out for. What's it, June? 6, 7. Okay. Although it gives you the exact results, six, 7, 8, I suppose. 7. Okay. So notice what happened here. Okay. Notice what happens here is that I am no longer seeking a particular value. I am now scanning. So if you want to if you want to quickly mental note, scan, read everything. While seek is why we have an index. Okay, so seek is really what we want the index to do, be able to find a record, right? And you'll notice that we are not actually using the index the way it's meant to. Okay. Now, on the other hand, the query produces exact same result. And you might notice that this overall, okay, is going to be slower in terms of the I/O cost, okay, and the CPU cost. For this case, because I have to apply 3 functions against every entry in my non-cluster index. That's the key. And also, I'm using this AND. That means I have to evaluate all 3 conditions. Okay, so I wouldn't necessarily tell it to say just use the index, because the problem here in that lies because I'm not using the column the way it should be used, right? The column is an order date. So an order date is a date. So try to minimize any conversions against, even if you do something like this. 2006. So in this case, this decided to do a whole table scan, call it a day. Because apparently there's a lot of records it thinks came out of that. How about something a little bit less? Okay. So notice, this time we're now back into index seek key lookup. So back to the question, would I, under any situation, use hint? I actually, like you said, I know SQL Server is smarter than me. That I already give up. I already have submitted to the fact that SQL Server knows more than I do, and it's like it's like when you're driving and like your better half always says, watch out for this, watch out for that, slow down, backseat driver kind of thing. Yeah. So folks, I'll take a moment of pause and see if you have any questions about how these index things are created and are used. Okay. Very cool. So each of these index, just be careful. Anytime you apply a function to a column, you might render the index useless to a certain degree. Okay. So speaking of the index, let's suppose I have an order date, and I usually would need my customer ID along with the order date. Okay. So notice, based on this operation, notice that the first thing I do is go to index seek to find that one order date and then do a key lookup. So if we can include the customer ID along with that non-cluster index, boom, we can eliminate this altogether, right? Because the purpose of this lookup is so we can find those columns. All right, so if you go into the order date, okay, that's what that included columns let you do. So let's say I would like to include the customer ID. Now I'm turning this query into something called index covered query. Okay, so meaning the next time I execute this, notice I no longer have to go to do another key lookup because everything I need is already there. I guess there's some record. Now we're happier. Okay, so notice now we don't have to go to the underlying table in order to find out, hey, what was the customer ID? Don't need to. Now, in fact, because our primary key is order ID, check this out. If all I need is order ID, just like you go to the back of the book and you look up an index and say, I need to know which page has the word apple. You don't actually have to go to the page to know the page number. Your index is going to give you the page number. So you notice that this query here is completely resolvable within the index itself. Does that make sense, folks? All right. Any questions, folks? I'm going to pause for like 30 seconds or 45 seconds, see if you have any questions, folks. You can ask the questions on the voice conference. You can also ask the questions on the chat. So long as you get the message, we're in good shape.
Victor,
Yes, please.
it may be hard to produce, but can you give us an example where index scan would be better than a seek?
A scan only means, okay, so here is how this works. Okay. An index logically looks like this. Okay. These are what we call the leaf blocks, this leaf page. So in the leaf page, they are, of course, sorted by the index keys. Okay. Now, above is how we can quickly get to places. So these contains pointers. So the first page will say 5,000 to 10,000. Look to your right. 1 to 4,999. Look to your left. And then this then contains pointers to say 1 to 1,000, find in this region, and another value find in that region, so on and so forth. So when you have needle in haystack, seek is always what you want to do exactly. Because let's say you have 10,000 records, you don't want to read everything until you find that record, right? So in this index can tell you with precision where exactly is 6,892. That's very easy to do. Look to your right, look for that region, and here is 3 pages. When you look at it, you're going to find it right here. Now that's a seek. Okay. Now, even when you're doing the range, it is still a seek. Okay. So when I say 5,500 and 5,600 between, even if I do that, it's still a seek because it's going to do, here's 5,500. Let me read everything until 5,600. So that's all my records. Right? Now, a scan means read every record. Okay. Scan means you have to read every single record. Perhaps you are looking for every single record. Or perhaps you applied a function. Okay, so let's say you did an ID mod 4. Let's say you apply this function, ID mod 4 equals 3. For some reason you wanted this where clause, ID mod 4 equals 3. Now, the index itself is not useful for seeking. Seeking won't do you any good, right? Because you're not going to be able to find all those records that fit those criteria. So scan must take place by reading every value and then mod 4 to see if it is 3. Next, 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 next. So the only way you can resolve is by reading the whole thing. Now, scan is justified, rightfully so, if you need every single value. Now, if it's a result of you applying the function, then you might have to think about perhaps can you query without that function applied? Okay. Or if you really have to query a certain way, maybe you can create a filtered index or an indexed view. Does that make sense in terms of seek and scan?
Yes.
Okay. Now, okay. Now, in SQL Server, there is this technique that you can do. Now, folks, remember, anytime you are speeding up data retrieval, it's at the cost of adding records. So, for example, what you can do is to create a virtual column and then index on the virtual column. Okay. Not a cheap thing to do, and usually you don't do it for a transaction-heavy system. Okay, you do this on a primarily reporting-based system. Okay, so now for the time constraint, I'm gonna direct you to look up computed column index in SQL Server. So you will find some examples on how to create an index on computed column. So if you must query with a function, then on that particular column, then try to use that rather than creating an index on a column that it won't be used. Okay, so you can create index on computed column. It's been available for as far back as I can remember. So it's not something new. Okay. So you have a notice that is called a computed column. The column is not hard-coded. It's based on the X value. Okay. And then you can create an index on that. So if you find yourself always apply a function on the column, then use that. All right. As long as we're on the index subject, there's one more thing I want to mention, and I'll let myself off the hook. Okay. Back to that orders table. So we have ship date, shipper ID, ship to postcodes. Okay, so okay, so I have the shipper ID. I guess that's a good example here. Okay. So I have 3 shipper ID, right? Fair enough. Let's see. Okay. Fantastic. So this is greatly evenly distributed. So I guess it's not going to be good for my demonstration. How about my ship city? Okay, you know what, folks? Just imagine this, okay? Just imagine there is... I'm going to add that. Okay, so notice the shipper ID 3 has 255 thousand record, or 2.5 million, whatever. There's a lot more compared to 249 and 326. Okay. So compared to that, you notice that would be a 99%. And that will be like 1% each. Now, it makes no sense to maintain an index on this column, including shipper ID 3. Why? Because if your where clause ever says that where shipper ID equals 3, guess what? Might as well do table scan. Right? Might as well just scan, because you are going to bring back 99% of records. The index is completely useless. Yet we still have to maintain it, right? So it makes no sense for this particular value. It makes sense for 2 and 1. It makes sense for 2 and 1. So what we can do is create something called filtered index. So let's suppose we have just show you where it is at the UI level. Okay, so if you find that, okay, you might say, okay, where shipper ID not equal to 3. So that will be a filter expression. Only build indexes for value beside 3. So that way you can minimize your non-cluster index size, okay, and not having to maintain those highly redundant value. All right. So most of this is aimed squarely at minimizing I/O. Okay. Any questions, folks? Any questions? All right, I'm going to take like a 45-second breather, 1 minute breather. If you have any questions, let me know on the chat, or just yell out, I have a question. I'll be like, okay. Anybody still here?
We're here.
Yeah, right. Any questions though? Does this make sense, or is just let me know if something you already know?
Definitely.
Okay. All right. Okay. Let me know if you have questions. All right. I'm almost well rested. I'm ready to give another run. I know I rest fast. Okay. So since you already have quite a bunch of hands-on experience with table value functions and common table expressions, okay. How are we doing with the analytic functions? Is this something that you have done quite a bit, or is this something? Okay. Anyone? Clean up my interface real quick.
What do you mean by analytic functions?
Cool. All right.
That's probably I'm probably muted.
No problem. No problem. No, I hear you. I hear you. So let me give you an example, right? Let me give you an example of analytic functions.
But
Okay.
that kind of answers your question right there. The fact that I have to ask.
No problem. So let's say we have a data that gives us daily sales total, right? Um, if you need to create a column that has running average, customer, so order, am I typing? Okay. Oh, okay. Did my keyboard just run out of battery in the middle of the class? Okay, it's not it. What did I just do? Folks, can you all still hear me? Okay, I know what I did. Okay. Is it tilted like the way I see it tilted too? Okay. Please tilt back.
I'm seeing nothing on my end.
Okay, good. My screen is just went sideways because I want to see if my keyboard's still working. Okay, that happens sometimes.